Hey everybody, Adam Savage here in my cave with another video in our series covering Princess cruise ships and their incredible engineering. Now, on this channel, we cover making in every stripe we encounter it in. I love covering watchmakers as much as I love covering the construction of skyscrapers. And the thing that surprised me the most at the beginning of our partnership with Princess was how fast these things get built. This is like an Empire State Building. It's literally as long as the Empire State Building is tall, and they build this entire thing ready to go in less than 2 years. That boggles my mind. And in this shop, I build everything like a bricklayer, one thing at a time, each based on the previous step, and then I eventually get an object. But a cruise ship like the Sun Princess is built in a fundamentally different way. It's built simultaneously, where every part is built somewhere else and then brought together. It's an incredible feat of systems management, and there's no better system to show you how this works than with the passenger cabins. There are over 2,000 of them, and every single one, in its completeness with electrics and plumbing and everything, is built off-site, brought in and installed. Let's let them walk us through this process because it is fascinating.
It looks like unbroken space, but this is all going to be cabins in a very short period of time. As gargantuan as they are, everything on a cruise ship is fighting for space. It is the premium, and the business end of the whole enterprise are the cabins. How do you fill as many people as possible on the ship while at the same time allowing them all to feel like they have spacious surroundings? There are ways to solve this problem with actual space and also with perceived space. And here's the cool thing about how Princess solves that problem. They don't do it on the ship. They do it here. I'm standing in a mock-up hallway with 4 different room types, and these have been built to allow the engineers at Princess to find the extra space, to see how the rooms lay out, and allow each one to feel like it has as much room as possible for the passengers. James, tell me about why this process is so important of mocking these rooms up out here.
Well, because on computer screen, on bits of paper, it all looks good. It looks perfect. We sign it off and we say, this is going to be fantastic. And then we know in reality, once we get on board and we put them in there, maybe things don't fit quite like we thought or don't quite look like we thought, or cardinal sin, we haven't used all the space that we want. And so that's why we come here, we build them one-to-one, real-time, not just the cabin itself, but the supporting ship structure. So you can see we've got the steel elements, ducting, pipework, everything going through to make sure everything is being accounted for as we put it all together.
So you've chosen like a specific part of the ship where the ductwork is moving through, and you're taking a look at all of it and how it fits together.
Exactly, all of it. So key part is the design, the interior design, and critiquing that and how that's all going to work. But kind of more interesting is on how it's going to fit within the ship structure as a whole. Because as you probably know, it's like a cabin prefabricated unit that slides into the ship.
Right, so that's the other thing that's blowing my mind, is that the cabins themselves are like cassettes that you will build in a building on the site, and then they'll be transported and slotted in.
Exactly, yeah. And so when you're dealing with that being slotted in there, obviously ship as huge as we've got here, loads of space, kind of, sort of in theory, but we use every last square inch of that space. And that's with the cabins too. And so as you're sliding them in, we got to make sure we've got enough room to actually slide in. But the tolerances are tiny. So that's great. But of course, our friends at the shipyard like to make sure they've got a lot of room, a lot of wiggle room, get it in there. And we want to make sure we get the absolute most space out of it. Actually, we work together to try and get the most space out of it, to be honest. But that's why we do it.
Were you able, in this mock-up, to find some more space?
Yeah, there were a couple areas we found little tweaks here and there, but there's one area that we did find quite a bit more space.
Now, I know we can't look into the cabins because you haven't worked out the interiors yet. That's fine, but can you show me where you found more space? I'm really dying to see that.
Sure. Do we want to walk over to it?
Yeah, we totally can. It's like stepping into a movie set.
Yeah, it pretty much is. So this is what we were talking about before. One of the areas we actually found quite a lot more space.
And this isn't a cabin door.
This isn't a cabin door. As you can see by the signage, this is where we've got some firefighting equipment back here, but we also have the functional piece of the cabin. So the wet unit, all the plumbing, the electrical, it's all accessible here. The reason why if there's an issue, we can access it here without disturbing somebody in their
Of
cabin.
course, you want to be able to do that.
Exactly. But
You looked in here.
we look to see part of the whole model room mock-up idea.
Yeah.
Let's make sure we've got all the best fit of everything and we haven't wasted any space. And what we did in here,
Wait, you found extra space in here? Doesn't look like there's a lot.
it's very tight, but as you can see,
Oh,
there is a little bit of extra space.
and that's what you're looking for, and that's enough to add a few inches to a cabin.
That's enough to add a few inches. And in this particular case, the inches were put on the entrance corridor. So it was a little tight, it felt a little cozy as you walked in.
Yeah.
And that could be recovered. Instead of just having it as wasted space, I'm sure the ducting and the electrical equipment would like the space itself, but it doesn't need it. Our guests would prefer it.
So after all the drawings and the CAD drawings and the fabrication that's already happened for these cabins, you can find space and adjust the build of the cabins live, as it were, while you're installing them into
Exactly.
the
So
shed.
these are done advanced enough that we can influence the whole sort of production line of the cabins.
That's
so yeah,
incredible.
it just shows the value of doing it. Not just from the design standpoint, have we chosen the materials correctly, have we
Yeah.
put the soap dispenser in the right spot, but also for the real mechanical part of it, make sure we've used the space to the best way possible.
I mean, I also imagine that, this is not a nominal expense to do all this mocking up, but for the sister ships that you will eventually build from this institutional knowledge carries forward.
Absolutely right, and we keep this too. So
Oh,
if
you
we
do?
need to come back and refresh, we need to revisit, something didn't work well on board, we wanted to change it, make it different, we've got these still here for a time being so we can do it all again. 'Cause you're right.
Incredible. And you can also do all sorts of different design choices and try out different looks and things like that.
Exactly right.
Man. That's a level of flexibility I didn't expect on a project of this complexity.
Yes, many areas there's no flexibility.
Yeah.
We make the decision, we go. Main engine choice, once that's set,
Yeah.
we're not doing a mock-up for those. But here, absolutely. And when you think of the quantity of cabins on board, even that little amount of space, if you multiply it over all of the cabins,
Yeah.
adds up to quite a lot.
This is so cool. You were saying earlier when we were talking that you started out designing military ships, but it's so clear from the way you talk about it that you just love this kind of problem solving.
Oh yeah, this is the good stuff.
I love this. I have built architectural models, 24 scale, of every space I've ever lived in because it helps me put the space into my body and understand it. It's also where I've often found how the HVAC is routed in houses, but I can see that the utility to doing this is just inestimable. It's amazing.
Absolutely, and just when you ramp up the scale from that small scale, whatever it might be on your computer screen, even just in that sort of model scale, then you get to this, you find everything.
And speaking of scale, there's over 2,000 passenger cabins and another 500-600 crew cabins.
It's even a little bit more than that.
More than
but
that,
yeah,
my
yeah,
God.
exactly. So it's a lot of cabins. So every last little bit makes all the difference. And when you're dealing with those numbers, gotta make sure it's right.
Everything about the scale of these ships blows my mind. Elevators, for one. This thing has 22 decks, and there are elevators that serve up to 15 decks at once, makes 15 stops. And that's not even the elevator that I'm most impressed by, because this yellow platform here is a temporary elevator. That is installed just so that the cabins can be loaded on one at a time like cassettes. And then one guy can receive the cabin up there and roll it into place and install it with these super, super tight tolerances. But I just love the idea of temporary elevators. That is like infrastructure for convenience and installation, and then it's all gonna go away and get installed on another ship. That is cool. So James, I'm really blown away by all the doors to this ship. All the different doors that are shaped like the hull and like all the different entrances. But this is the specific main embarkation entrance, is that correct?
Exactly right. Yeah, there's loads of doors. We've got garbage doors, we've got embarkation doors for machinery, for our food, for the baggage, for the guests,
theater.
for the crew, for the theater.
Yeah.
Absolutely. We've got doors for everything.
But this is
one,
unique.
Absolutely. So what's really neat about this one is the size. I mean, if you just look at it, it's 3 decks high. So we're going from deck 3, deck 4, deck 5, and we're providing embarkation into the same point of the ship, but from all these different levels.
And that's brand new for Princess.
Absolutely right. Yeah, so we couldn't just go and buy this right off the market. We had to go and sort of spec it out and work with a few vendors, with our partners at the shipyard as well, and go out and have this developed for us. So we're seeing part of it coming in. Obviously be far more impressive once we're done, but it's there where we're at right now.
But before this, what would happen is you come into different ports and have to bring people in at different levels.
Exactly. When the ships were much smaller and the ports were a bit more consistent and able to deal with it, it wasn't such a problem because you could have just the one embarkation area. So everybody could come in, you could put your gangways out in a very traditional fashion and know that it would work. But now, with the variety of ports that we like to go to, with the size of this ship,
and they're all different sizes.
All different. So we've got tidal ranges to worry about, we've got different pier heights to worry about. Some places we've got a nice sort of airliner-style jet bridge that attaches to the ship. Other places it's almost like this, and we have gangways just going across. So to be flexible, that's why we went for this one.
It really feels like the Sun Princess is a platform for a gigantic number of new technologies for Princess.
There are a lot, and a lot of them are sort of small tweaks. So you would look at it and say, well, this isn't, the ship isn't going to rise up on thrusters and fly around the world. It's not like that. But there's lots of individual ones that do that. And as a whole, it's going to be quite impressive. It's going to be a change for our Princess, for our team on board, hopefully for our guests too. Hopefully they're going to look at it and say, yeah, this is great.
So I'm curious about how these systems come in, because this wasn't built in place. It was built somewhere else and brought into here.
Yeah, like most of the systems on the ship, it's really impractical to build them in place. And when you go through the ship, you can feel how sort of tight and narrow a lot of the engineering spaces are. We use every last bit of space on board.
This is the thing that blows my mind, that this is 10 months of work. And it seems only possible because instead of building it like Legos the way we think of normal building, you guys are building everything concurrently and then just bringing it all together.
Yeah, lots of systems, subsystems, and even big sections of the ship built all concurrently out here in the shipyard or in the supplier factories, and all brought together at once to sort of be loaded on and create this giant structure in that short period of time that you mentioned.
So how many different, do you know how many different factories you have contributing parts to this?
Oh, that would be very difficult to answer. There are a lot of different factories, and there's suppliers and sub-suppliers, but of course we've got our key ones. And when we think of the ship as a big structure, big steel structure, we've got two big suppliers. Obviously Fincantieri here in Monfalcone, but there's also the shipyard in Romania, in Tulcea, Romania, who supplied a significant part of the ship already built and delivered it to this dry dock, ready for all of the other pieces to be built around it.
And from what I understand, they're already building a part for the next version of this that's going to come in.
Yeah, we're not even done with this one. We just launched this ship, and still, we've got another ship already well underway. The LNG tanks there being fitted into the ship, and so already well underway, in progress.
Yeah, someone was telling me that this dry dock will be empty only for a few days before the next ship starts getting welded together.
Yeah, it's incredible. The number of dry docks that you can build these large ships in, they're very few in the world, so they are in high demand. So they like to get us out as quickly as possible and get the next project going and have that built up. So there'll be a long time for this ship to be alongside the quay nearby, and we'll do all the fitting out and all the beautiful work on board for the public area outfitting and make sure the cabins are up to scratch. But this prime steel, the good hardcore bit, yeah, it's pretty quick. It's this 10 months here, and we get in and out, next one comes along.
It's like the pyramids in a quarter of the time. Okay, so I'm picturing you have a team of people that are monitoring how stuff is being built in other places and making sure it's getting here on time, roughly. But then how often does something come in and it doesn't quite fit and you've got to adjust just a little bit? How do you, there's got to be so much contingency planning.
There is, and there's a lot of, I'm just going to say banging of steel.
Sure.
So as we put the pieces together, the tolerances are very good. They're very tight and they come together very nicely.
Because space is at such a premium.
Absolute premium.
Even this large.
Absolute premium. And over the years, we found that we've been able to dial those contingencies back. Because once we have the final product, we go in and we say, that's just empty space.
Right.
We could have used that for something else. We could have actually run more piping through there, been more efficient with how we do our cable runs, and hopefully the ultimate goal is to provide more space back for the guests on board.
And
something cool, have another bar, have another restaurant.
It's all about building that institutional knowledge so that you guys don't have to constantly do that contingency plan.
Exactly. If you were to start from scratch without any of that, you'd have to build in such huge amount of contingency because you'd just be unaware of where everything goes. But nowadays, with when you compare to shipbuilding of old, where there was a lot of experience, there was a lot of sort of, let's have the guy come on, and whoever got there first got to put his stuff through.
Right.
So you had a hole maybe this big,
Yeah.
and if the guy with the water pipe comes through, well, he's getting that. And then the guy with the cables, well, he's going to have to go find another hole and cut it in the bulkhead. Now with all the 3D modeling that we do, everything is exactly modeled out. So we know exactly how much space we need for each of the systems. And there's no longer, like in the shipbuilding of old, and I'm talking like the 30s and 40s and 50s, there's no longer that fight between the trades of, well, I'm going to get there first and put my stuff in, and you're going to have to wait. Now it's all very precisely controlled and modeled out ahead of time.
It also speaks to, I mean, everyone I've been meeting has been working for Princess for a long time. You know, I think the shortest is about 9 years and, you know, is up to 20 years. That's really important for holding on to that kind of knowledge, isn't it?
It is
that team
important for it.
continuity.
Yeah. Well, I mean, it's cruising, so it's kind of fun to work for anyway.
Right,
So,
clearly.
so people do like to be here, do like to be part of this team. And these kind of projects, I mean, they're just a joy to be a part of. I've been with Princess for 15 years. Before that, I was naval architecture. That's my background, so I kind of love the big steel structures.
Yeah.
That's what I like doing, so it's great to be a part of this.
Do you have a favorite part about the building of the ship, the part that gets you really excited?
So that's a good. So a lot of naval architects will tell you they want to design the next America's Cup yacht. That sort of Formula One type thing.
Yeah.
Not me.
Not you.
No, I like the big steel ship. So I like the fact that this is as large as it is, while also being Panama compliant, which is kind of crazy, really, when you think about it, that this size of ship is still going to be able to get through the new Panama Canal locks. Not the old Panama Canal, not the Teddy Roosevelt locks, but the new ones. But to be able to put as much sort of volume into this to allow all the different experiences on board, while also given that flexibility to go through the Panama Canal, which is a great experience to do by itself. But just that repositioning between East and West Coast and doing all of that, it's fantastic flexibility and great for the ship, really. So.
With all of these new systems, the LNG and the air lubrication systems, the modularity, this new embarkation door, you guys must do a ton of testing to make sure all these systems are already robust when you're installing them.
So sometimes I would say too much testing. We like to be really sure that a lot of it's going to work. Some of it's very sort of fundamental and needs a little bit less testing, but you mentioned the air lubrication system. Yeah, we did some testing on that. We've done some real life testing, we've done model testing, we've done computational fluid dynamic testing. A lot of testing to make sure it works. Because it's not just a big investment, but it's a complicated piece of machinery to have on board with the air compressors, the piping through the double bottom, and all those air release units. I think we've got 14 across the flat bottom.
7 compressors.
Yeah, we need to make sure it's going to do what we want it to do. And we're quite sure it will. So.
Gaetano was giving me a tour of the underside of the boat when I first got here, and I just had no idea how many different systems, from the nose to the thrusters to the stabilizers to the air lubrication to even the propellers on their.
Yeah,
I can't remember what the name of those things are.
The Azipods.
The Azipods. My God, they're so cool.
So the Azipods, I am quite excited by it because Princess has been a little traditional with our shaft lines and propellers like you see on most ships. So Azipods aren't new technology, but they're new technology for us. And what's really important, ship this size, it will bring maneuverability and it will bring efficiency.
I mean, I think that most people would look at a company making things this big and think of them as super risk averse, but it feels like all of this innovation is coming from a place of like, yeah, let's keep trying new things and keep on trying to make it better. That's really exciting.
Yeah, we've got lots of teams who are looking at the future, what we can do differently on the next ship and what we can retrofit on the fleet currently, and what should really be a future technology that we're building on to the next platforms, putting into our next shipbuilding contracts.
So there may be something that you guys install in this ship that works so well, you might retrofit it into an older ship and try that system.
Absolutely, absolutely. We do that all the time. Once we've proven it somewhere, if we can make it work elsewhere and it suits the platform, suits the mission, yeah, absolutely.
There is one fact I heard during the ceremony yesterday that blew my mind. Is this true that you are also using the LNG and Boyle's Law to create air conditioning from the LNG?
Yeah, so there's a heat recovery system. So absolutely right. And we've got a couple of absorption chillers on board. First time that we've been doing it.
That is so cool.
I think it's going to be
the
great.
gas is a gas. It does the
Yeah,
same thing that any
exactly
other
right.
air conditioning gas does, but I just love that you're using the fuel
We
to
look
do
at
that.
every opportunity to use and reuse because, I mean, the easiest thing when we're heating something up, why let that go to waste?
Yeah.
Let's use it. So,
James, it's just thrilling. Thank you so much for
very
walking me
welcome.
through this.
Glad to be here.